Welcome to Lecture 4 of MCS 472, a course on industrial mathematics and computation. So, in this lecture, I have three important points to make. In a sense, this is a restart, so it's also an advertisement for the course. If you are just thinking of joining up, welcome. And the second point, the second topic in this lecture is a list of proposals for the first project. So in a way, if you're curious about what this course is about, then I hope that the list of topic proposals will satisfy your interest. And then the last and important part is on technical writing and the presentations of projects. Okay, so industrial math and computation. What is that actually? Well, here is a very brief summary of the first part of the first lecture. We solve problems in industry, science, and government. So no matter where you will be getting employed later on after you graduate, you will have to be able to solve problems in these three sectors. The emphasis in this course is on projects, on technical writing and presenting. So in some sense, this lecture of today represents the core of the course. It comes very early because we will repeat this. How do you learn something? Well, you learn by doing. The third important aspect is that collaborations are actually strongly encouraged. They're not mandatory, but if you can work in teams, then so the better. Most important problems are too important to be solved individually, and your ability to work with other people is important, whichever sector you land in, industry, science, or government. There is homework, so we have our first homework assignment that was announced last week. Homework is actually meant to explore potential topics for projects. So there are also exams, and there will be a final exam. That's mainly to kind of get some familiarity with the main techniques, with our main methods that we are using. As there is an emphasis on projects, there are 3 weeks in this course which are budgeted for project presentations. So an important aspect of this course is that even if you would decide to work on your own, I hope that you learn from your peers. And I'm also actually looking forward to those 3 weeks. So in some courses there are projects, but they come all at the end, entirely at the end of the course. Here we will have already our first week of project presentations within 3 weeks. So that may look a little bit scary, but we will learn by doing. We will learn also by making mistakes. So if something goes wrong in the first week, we will have a second week of project presentations. And I hope that you learn from the feedback that you receive. Here is about working in pairs. So I copied this slide from when I teach Introduction to Computer Science. So you may have done collaborations on computer projects. And be mindful of the bottom line here. So homework are isolated problems to somehow get you a feeling of what a project could be. So in the list of proposals of the topics, I will also try to indicate to which homework they are connected. So therefore, it makes sense to actually also make homework in pairs. If you work in pairs, there are two fundamental different modes of working in pairs. With pair programming, when you meet, you do the work. So there is one person who does something. So if you share a Jupyter notebook, then the one of the members in the project will do the computations, will do the coding, and the other person, which is called the navigator, will check and comment. And one can switch from time to time. So I mentioned CoCalc earlier. CoCalc is for collaborative computations. It is possible within CoCalc that two people work remotely, and share the same Jupyter notebook. Then there is the alternative, so that's code review. When you meet, you actually share. One reports on the work, and another reports on the feedback. So it's important to, if you work in a pair, that you agree or that you realize which modes of computations, which modes of collaborations that you are using. With pair programming, you do all the work during your meeting. With code review, you agree first that you will do some work, and then during the meeting you will report on your results. So then you will go through a Jupyter notebook, scroll through, and indicate what are your results, what are your difficulties, what you still should do. So there is also a reviewer and there is a coder. In many of the topics for the project proposals, there are several parts, and actually there is the writing and there is the computing. There is the solving of the projects and there is the reporting on it. You should not wait on writing the report all at the end, so you can interlace things. So you can, if you work in a pair, you can say that one person will focus on the writing, the other person will focus on the computations, and the roles will alternate, may switch, and should actually switch from time to time. Okay, so you are allowed to make homework in pairs as well. I hope that this is somehow an incentive to consider working in pairs. Before you work in pairs, commit. So it's not that you look for a partner the hour before the deadline. That's not appropriate. All right, so at this point I should pause a little bit. So I'm in almost 10 minutes in this lecture. If this is an interactive lecture, so if you're watching this before the actual class meeting, think about questions you may have. So now I will go through the list of the project proposals. So the first week was on statistical reasoning. So we had the cumulative distribution function. The question is, this is often modeled by one explicit formula, but it's actually also often for a specific problem, it's a data fitting problem. There are two parts in this project. Again, if you work in teams, in a pair, one person can get the actual data. So you can look for mortality data. There are public databases around. So the Illinois Department of Public Health has a public database. A lot of government data is actually also available in raw format. There are websites out there that provide interfaces, and they are often requiring compensation for this interface. But the raw data itself, especially if it's collected by the government, should be public in the public domain. So you can look for a database. Alternatively, you could do the gathering yourself. If you are a reader of the notices of the American Mathematical Society, then you can see that there is always a column there, a section that reports on the deaths of the members of the American Mathematical Society. If you're interested in the cumulative distribution function for that particular group of people, this would be a data collection project as well. So this would be a third aspect. The normal distribution would be suggested, but is it actually really normal? In the first lecture, I had a reference on the 40 on 40 commonly distributions. So there is a separate distribution for the weight of people, because there are outliers there, and the outliers are not as exceptional. It could also be that in the ages there are outliers there. It could be that, so the other question, so what you should answer are these two questions here, but there is a lot of fluctuation there. So there are a lot of interesting questions that can be answered there. Which populations are, you could also, yes, you can do a lot of other questions here. But these are the two questions you could focus on. So if you took MCS 471 on numerical analysis, or if you want to know more about spline approximations, this could be, so splines are piecewise polynomial functions. So for every H group or the probability, you may use a different polynomial. So splines are very flexible in this sense. Could be that it's not at all polynomial. Most likely it is not. Okay. Another question, the Poisson distribution. We stipulated that the Poisson distribution should be used. So last week, that's standard practice if you simulate the servicing request. Should this be, but do you believe this? You can gather data. So this is also a data gathering. So here I mention a store, but you could also sit, if you like public libraries, you could spend one day in a public library and check how many people come in every hour, and then model this. And you could, if you're doing this with a partner, you could alternate. So if you do your work in a public library because of good internet access, you could, that would be an interesting data gathering project where you would sit there for, let's say, 5 days in a week at one particular hour, or instead of doing one entire day. Alternatively, there is the servicing of internet requests. Some public databases may actually advocate, or if you have access to a public web server, you may have the traffic, the website traffic. Some websites might actually even be advertising this. Here is how popular our website is. So the question remains the same for arrival data. Then model the probability density function and the cumulative probability distribution. So this is again a statistics project. Is the distribution actually Poisson? And if so, what is the value for this lambda parameter? If it's not Poisson, why not? And what is a better distribution? Okay, so we had the staffing exercise. So the staffing, the staffing example of the example for the binomial distribution in the first week I think it was the second lecture. The exercise, there was then an exercise that asks you about the concern to overbooking in an airline. Here, this is a follow-up. So it has parameters. So we assume that, and it is an abstract model. Again, the way to start on this project would be to solve the corresponding exercise. So here, if there are two people interested in the same project, then I would suggest that also you solve the homework problem jointly. So the exercise is set up with letters, so with parameters. The exercise of lecture 2 gives specific data. I think I suggested the N, capital N, for the number of seats, take 100 seats. And the question is, can you, what is the probability with a confidence that you can seat everybody if you sell 105 seats? Here we have these parameters. You can also do this with Monte Carlo simulation, although here it is suggested that you are using the binomial distribution. So the binomials, the distribution that we introduced for the staffing problem. I should say that if two people are interested in this project and there is really the strong desire to work individually, then the staffing problem could also turn into an alternative project. So scheduling work schedules, job schedules, is another important problem. Here we are interested in the two questions. So the reparation. So you could think of R equals to L. You could actually thinking of this problem. So to motivate you, you could be a federal oversight organization. So what the maximum reparation is. So you could think that so there is an answer immediately. R should equal L. So you give the return, but it could be that the customer is inconvenienced and is entitled to more. What is reasonable for more than just the price of the ticket, given that there is the overselling. So if there is a problem that's really interesting to you, in the second project, in the second round, we will be more focused in cost-benefit analysis. So one can look at the necessity for overbooking, which benefits actually everybody, that the overbooking, and given that a lot of people may not show up, that the overbooking strategy leads to more affordable airline travel. Okay, so the first two projects were data collection problems. Here, and the last project was more a modeling and a design issue. Here we have already solved the design problem. So we have designed a lottery, and actually I picked the data on this slide from a website that describes the prizes and the odds of winning in the Illinois lottery. So what is actually the justification for these numbers? Why would you give 2 million? So if you give a prize of 2 million, if there's 1 in 15 million. So it actually means that you would expect that not in every given period where you run your lottery, there are actually not 15 million. But the 2 million is, of course, the jackpot. It's the once in a lifetime. It's a life-changing amount, and this might be the main the main selling point for the lottery. But then also at the lower end, the lower end prices are actually more. So when you organize a lottery, is this something that benefits society, and it benefits the state? So it's another way how the state collects its taxes its citizens. Um, the justification is the probability analysis that you do, and then there is the expectation, the expected return. So how can you solve this? You can solve this by reasoning probabilities. You can also do this by simulation, a Monte Carlo simulation, running this lottery with this payout. You can run this lottery. So you have 1 million tickets. So you have 1 million people who buy $1. So that's your income as a lottery organizer. And then you run the probability game. So you essentially have 6 different outcomes. So in the most likely outcome, the lottery ticket is a loss to the buyer. So you run an unfair or a very specific loaded coin with these probabilities. And then you have the expected return. So 1 and 2 can actually be solved together. So Monte Carlo simulation is very powerful. Okay, what is the loss of quality? So we've seen Takeuchi quality control. And this can also be solved here with Monte Carlo simulation. We have to, if you run a store, you may expect that if there are long waiting times, that customers may not return. So that will lead to a loss in customers and a loss in revenue. So if your store is too busy, that's also, for example, one of the motivations why, for example, the Poisson arrivals might not be such a good model. In some stores, there's a very limited capacity, and if the store is full, people will simply not enter. So that could be another motivation why a Poisson distribution might not be the right model. But here we have to consider two competing considerations, and that's also actually a staffing problem. You have to decide as a store manager how many cashiers you will employ. So if you have too few, then you will have too long wait lines. If you have too many cashiers, you will have a loss as well, because you have to pay them by the hour. You don't pay your cashiers by the number of people they check out. Okay, so Monte Carlo simulation used this to determine the mean and the standard deviation. So in a way, this is also a data collection. When we designed the quality loss function, we gave specific numbers. So when something does not meet the target, there is a loss. There is a production. There is a mean that comes from the production here. Simulate what is the average wait time, simulate what is the idle time of the cashiers. So this invites you to run the simulation program for lecture 3, where we computed the time, the busy time of the processor. So, but we were then mainly interested in the wait time and the standard deviation. So the program outputs the wait time of the customer and the standard deviation. You have to modify this program that it also gives the busy time of the processor. Um, so the servicing request, we think of stores, but you can also think of running a big expensive supercomputer. Having the supercomputer being idle is very bad, because you may have your constant cost of your power. So you have to keep your computers up and running, ready for jobs. If there are no jobs, that comes at a loss as well. So if more people who are do not want to work in pairs are interested in this problem, then I can think of an alternative formulation. All right, we ran Monte Carlo simulations, and this is looking for if you have in some, so in Julia we had the rand function and we had the rand n function that simulates a normal distribution. But how can you actually make a normal distribution if you only have a rand function? Well, this could be an algorithm to do this. So you could flip a coin many times and average. So if you have the fair coin, so you generate a random number in the 0, 1 range. If it's less than 0.5, you call heads. If otherwise, you call tail. So you have a 0, 1 coin flip. If you average them out, so divide by the square of the experiments, you actually do have a normal distribution. So points 1 and 2, so the showing that you can do this with expectations. So it would actually be a good exercise to at least write the definitions for the integrals. And you can solve those integrals numerically if you took MCS 471. So you can solve the first part numerically via the integral definitions. So we saw the definitions for the expected value and the standard deviation when we did Takeuchi quality control. It can also be commingled with the Monte Carlo simulation. So the second part is again Monte Carlo simulation. Okay, here is then a similar project. So we had the Poisson random number generator. So I listed the code in lecture 3 that was copied from the Art of Computer Programming. Now assume that we didn't have the Poisson distribution as available in the StatsKit package of Julia. So we have to program this ourselves. So this could be useful if you are a programmer working with self-contained code, and also that there might be constraints on using external software libraries. So, but mainly it is also to get a feeling of that random number generators on a computer are always quasi-random. Okay, so it's a programming exercise. So you should, you of course with Julia, it's implementing this and comparing. So you can so 1 and 3 you could do at the same time. So check whether the numbers you get from your algorithm and getting from the Poisson distribution, if you specify lambda, so how should you do this? You specify a lambda, and with large numbers, the observed or the generated numbers should be around the lambda. Also, the standard deviation should be the square of the lambda. So there is a check. So in some sense, you will see that if you do this with 10 experiments, the numbers will be entirely different. But if you have 100,000, a million numbers, then there should be a credible, a plausible expectation here. So I hope that there are 7 projects. So 6 students are enrolled in the class. So it's theoretically, technically possible that you come up with the all different choices. But so feel free to check among each other whether people have the same interests. Okay, what are the deadlines? So this lecture happens on Wednesday. By Friday, or actually preferably even sooner, you should have a topic in mind. So the topics could be getting your nose into real data, doing a computational project that is self-contained. Well, the computations are actually a common denominator. You will have to compute, but either your computations can be done on purely synthetic data, so random numbers that you generate, or random numbers that you simulate with Monte Carlo, or then on actual data. So if it so happens that people choose the same topic, then I will suggest that you collaborate. If not, if there is really a strong desire to work individually, then I can indicate what topics are still open, or I can suggest a reformulation of the topic. So the projects will be presented, and what makes the course interesting and exciting is also that you see how how your peers have approached the problem. So in the extreme case, suppose that everybody wants to do the same topic, then the third week might be rather boring. So I hope that there is a sufficient diversity here. It's not so that you have to work on this very intently for 2 weeks, but still, the guide of the main principle of doing good quality work is to start early and to work often. So in the 2 weeks time, that is between Friday the 21st or Monday after the 24th, when we meet again in person, and the start of the project presentations. So in between there, I hope that if you can spend some time regularly during these 2 weeks, that the third week might be the week of Monday, 7th February, will be a very exciting week for all of us. All right, so this is the second important part. So the topics. Now, this course is also on presenting and presentations. So I should say this course is starting online. I will keep on the possibility that the course keeps on running online. And I will indicate how you could present also online. So I will keep open the possibility for hybrid runnings of the course. Okay, so writing. So you have a course, Math 300, writing in the discipline, that's entirely focused on writing. Here, writing plays a very important part. So I will now present 2 separate presentations. So in some sense, this is a lecture within a lecture. So there are 2 collections of slides that I borrowed from the sources, which I will list at the very end. So, what is the formal technical report? So there is writing. So if you keep a journal, if you write about your adventures every regularly, that is personal writing. Here it is formal and it is technical. So there is an author there. If you work in pairs, sometimes a very badly stitched report is that you can see an abrupt change in style. And it's clear that the first half was written by one person and the second part was written by another person. So the technical report should be formal. And there is a way to make reports formal. So I will list the elements of a technical report. What is the detailed structure? How should you start on writing? And how should you approach this? And also, what are the technical aspects of writing? 4 parts. First, what are the elements? So every technical report should have a title and an abstract, should have a table of contents, and also the terminology should be made specific. There is an introduction, which is separate from the summary, and there is an analysis. Then there are the experiments, so you should list the equipment, which means what software did you use. There are results, and there is a discussion about results, and then there are conclusions, references, and appendices. So these are the elements of a technical report. I will now go carefully through these elements. So first, the title. The title should not be too long, not be too short. 7 to 8 well-chosen words. So it should fit. So in a way, the topics, so the proposals of the topics are already giving suggestions for clear for what the title could be. You could also work with titles, but if you really want a short title with 3 words, you could work with a subtitle, which is longer. You could also work with parts. So the textbook that we are using for this course has one part and then colon problems in. So there are subtitles as well. So there are titles that consists of parts as well. So then there is the abstract or the summary. So the summary should actually be written or finalized at the very end. It's not an introduction. It's also not a conclusion. It should be able to, one should be able to extract this from the report. So it should be standing alone. Also, very simple, 1 or 2 paragraphs. It's in some sense the most important way. One way to look at the abstract, so you may start with the title. The abstract is in some sense most important, and it should be finalized after the entire project. But you could also start by explaining the title. So that's also a good approach of writing the abstract. So it somehow writing what you really want to say with this report. Okay, so there are the titles and then there are the section headings. So sometimes the table of contents is automatically generated. Um, so the table of contents is important if you think about the structure of your report. So think about the table of contents. So the introduction could be replaced by problem statement, or you could have introduction, comma, problem statement, comma, motivation. Here, I was indicating what every technical project should have, and that could be the default section headings. Um, 2.4. So you so the list of symbols, the acronyms or the abbreviations. Um, we've seen already the PDF and the CDF, the probability density function, the cumulative density function. So the QLF, the quality loss function. So the abbreviations are very important for the natural flow of a text. The quality loss function, if you abbreviate this with QLF, then it would be good for the reader who sometimes leaves through the report that there would be one common place where to look up the dictionary between the common terms and others. In the text, so the importance is also you should actually spell out the abbreviations when they occur first. So there is somewhere a definition. So if you are using the quality loss function for the very first time, you should spell it out there. And like is done here with the fast Fourier transform. The introduction should do three things, but most importantly, it should encourage readers to read on. So, what are the questions? Why these questions are important? Why and why somebody should read it? So that's most important here. So, in some sense, as you are selecting your topic, why did you choose it? Why do you think that this is such an important question? That's important. You should provide the background. What is the context? So, in some sense, this could follow from the first motivation. What is the context here? If you think about the mortality, so there are plenty of statistics out there now with the pandemic. So you can make that clear there. It's also then giving a preview of what follows. In some sense, this is not the table of contents. It's also not the conclusion, but it hangs on. It's also not the summary. So the summary, the introduction, and the conclusions, they kind of hang together, but they serve different purposes. The introduction is really meant what it does, it introduces for what follows. The context of the work could lead to the analysis. So, what is the mathematical basis? So, if somebody is not familiar, if you are describing the probability density function, then here could be the place to put it. Here could be, if you do Monte Carlo simulation, this could be here where you decide on the mathematical justification for your work. So at this point, you may already cite from the literature, and I probably should have pointed this out also in the introduction. There is the background here. It's sometimes good practice that everything that you cite, all your sources, are already mentioned in the background, in the introduction. What are the sources that you used? What is the literature? The purpose here is that your report should be self-contained. Here by self-contained, I means that you should not somehow copy the entire lecture content. So important, who's the reader? The reader is your fellow student. So also for the project presentations, you are going to present this to the other members in the class. So you may assume that the readers of this project, the readers of your technical report, have actually gone through the class materials. Okay, and then comes the actual work. So you have your experimental equipment. The keyword here is reproducibility. So your Jupyter notebook is here actually your procedure. So I have tried with the posted Jupyter notebooks to kind of include and try to be self-contained here. You could actually, when you are doing your experiments, you could actually use the Jupyter notebook also as a way to structure everything. So you could make your Jupyter notebook self-contained. But your Jupyter notebook is actually not your project. You could see it as a rough draft for it. But reproducibility here is important. And what computer did you use? What version of Julia? Which libraries? You will present computational results. Already, if you took MCS 471 and did the projects there, what was already important, what I tried to do there, was that you would explain, would write at least one paragraph about the observations. Raw data is actually not acceptable in the technical report. I will repeat this here. Raw data is not acceptable. Just a listing of a program, just dumping numbers is not. So there should be formatted tables. You should also provide pictures. So if you did the data analysis, you have histograms that you can make. Every table and every picture should have a caption, so a legend. You can, that's a style issue, you can have self-contained legends for whole sentences. But alternatively, and perhaps preferably also as well, for every table and picture, you could have a paragraph. And the bottom line here on this slide is that you should, in that paragraph, refer to table 1 or picture 1 or figure 1. So every figure should have a label, a caption, and should have a description. Because sometimes people look at the pictures first and then start reading. Reports are not read in sequential order often, but they should be able to. Then the results. So this is somehow a summary, so it's not the abstract. You should provide an analysis. So this could be where the readers jump immediately, so people will decide whether to read on, whether your results are there. This is separate from the experiments. Also separate from the discussion. So a good technical report in the introduction may have a hypothesis. So I formulated a hypothesis with the overbooking strategy. So what is the reparation that you give a customer who is turned away while you refund the ticket? Is that reasonable or not? So how much more should you be prepared to offer? Or perhaps not, or perhaps that's too generous. Perhaps you had very precisely stipulated that this is an economy ticket, non-refundable. So then actually the refund might be too generous here as well. So there are several scenarios that you may. Okay, so you make certain assumptions. So in the discussion session, this could be where you kind of say that yes, we had these results, but we made these assumptions. So one can often manipulate data depending on certain probabilities. So here, this is where you can open up your assumptions. And where you could say, look, we had this hypothesis. We made this hypothesis because that's what we desired and what we expected. But we got very strange results, or we had results that were there. So here is where you can digress. Here, this is a potential interpretation. But again, it's a technical report. It is logical, it is technical. It should be formal, not personal. Okay, so then the conclusions. So the conclusions is not the discussion here. So you should not open up the discussion now. So this is a restatement. Okay, the references. So here is how you can cite them. It's also a very good resource. The Elements of Style. I mentioned the fourth edition, but there is already many more editions. So this is a classic. I have a paper copy in my office, and people recommend that every year, if you do writing, every year rewrite it. It's a short manual on style. Then I mentioned raw data and reproducibility. So this could be if a report is seen on paper, this could be printed, but this could also be a link to an online resource where you have the public version of your Jupyter notebook. You can upload it in CoCalc and make the link available. So that is, or do this on another website. So that's an alternative. But you could also do this for your appendix. So in some sense, I mentioned that raw results are not acceptable in the main body of your technical report, but they might also be desirable as an appendix. If you have a table of timings that were then used for a picture, then the raw timings, the table of timings, which often is not so illuminating, the picture is more and is the main result, but then the source code, how you made the picture, even can also be in the appendix. Okay, so that's the first part. Then I mentioned pair programming, pair writing. So you can start early and often, revise. So who will read your report? I will read it, but it should be aimed at your fellow authors. So this also means that working in pairs have the benefit is that you have feedback. If your partner does not really understand what you wrote, then that's a red flag, a clear signal that you should be working better. Okay, I mentioned the Jupyter notebook where you have Markdown and LaTeX. So your Jupyter notebook is recommended to work, but you should actually now deliver a PDF file, not a Jupyter notebook here. So that's the raw. Sometimes I write by hand if I want to turn off my computers and just have on the fly some inspiration. You can also write on computer. In any case, use a spelling checker. If there is a spelling mistake, that is sloppiness. It sometimes suggests that you didn't even read what you wrote. So, okay. I do not want to go over time, and I'm afraid that I'm already over time. In that sense, I'm violating now the main principles on good project presentation. Stay within the budgeted time. So this recording is not stopping me, so I apologize for going over time. So I'm violating the first rule already of a good slide presentation or any good presentation. So there is the do's and the don'ts. What are the essentials? Why do we use slides? Why did I use slides? At some point, I switched to slides because of the secure structure. It is suitable for listing topics. Make sure that you do not forget anything. And here you see that the slides that I'm using are following the best practices, precise and concise. So do not overload slides. So that is already the point here. People turn off if you put too many lines on a slide. So I violate that often, and that's because of the secure thing. So the worst thing that you can do is you have your project report and you are dumping paragraph after paragraph on your slide. It make your slide presentation also while you're writing your project. So that's also one of the good things of aspects of technical writing. How should you approach writing? Think about how you should talk about your project. Okay, so keep on eye contact with your audience. I mentioned actually presenting, so I will say something more about this. So slides have the virtue that you can face your audience. In the recording here that I'm making, this is awkward. So you tell a story. That's the important thing. You have some points that you want to make. So there are sentences. So I've transitioned now from one part to the second part. It is so know who you talk to. So it should be accessible to your peers. It's not the technical report. Do not assume that when you present in class that others will have read the report. Think also about the short presentation. So we will actually have more than 10 minutes. So we have 3 lectures, 50 minutes. So it will not be 10 minutes, but you will have 20 minutes time. But the 20 minutes or the 10 minutes, they pass very, very quickly. The content, be precise, be concise, be ready to answer questions. What is your motivation again? Why did you do it that way? Why did you choose Monte Carlo simulation? Summarize the results and the conclusions. There is a clear so you could hand written your slides. So prepare for 10 to 15 minutes. They go very well. No more than 8 slides. So here you can see I have 35 slides. So I go way overboard for my 15-minute presentation. I should have known this, but the recording does not prevent me from going over time here. I'm aware that I'm at the hour. About rehearsing, for this recording I'm using the Open Broadcast software. If you need help with this, so and also if we are still forced to work remotely, or if you have things that prevent you from going to campus, you could have a recording that is presented. I would recommend that you would actually pre-record. So this is an excellent rehearsal. With team members, you have feedback, but if you watch your recording afterwards, you have your own feedback. So uh, prepare 10-minute presentation and then watch it. And then watch it as a objective observer. Okay. So I hope that this was useful. Here are my main sources. So there is chapter 15 of our textbook, the textbook that I'm following. The proposals of the objects are also adapted from the exercises in the first two chapters. So this was an important lecture. Perhaps that's kind of my excuse for going over time. If you have any questions or concerns, feel free to contact me. Um, I hope that this lecture, the slides are helpful in giving you an idea what the course is about, how the course will run, and I hope to be as flexible as possible.